Hi everybody. I'm going to make a video today to help you out with 1.3, greatest common factor. We're going to learn how to use the prime factorization of two numbers to help us find the greatest common factor of those two numbers, which is the biggest number that I can divide out of both of those numbers. Now, last week, let's get this out of the way. Leave. No. There. Okay, last week we learned that if I take the prime factorization of a number, like here I have 24 and its prime factorization, all the factors of 24 can be written as some combination of these prime factors. You can see I did that here. So 2 is 2, 3 is 3, 4 is 2 times 2, 6 is 2 times 3, 8 is 2 to the third, and 12 is 2 times 2 times 2 times 3. And of course 24 itself is all the prime factors multiplied together. So I just wanted to do a quick overview of that before we move on. It's kind of important to know that. All right. So if I have two big numbers and I don't know off the top of my head what the greatest common factor is, we actually have a way of doing that. So I'll take an example here. We're going to use 70 and 126. So let's say that I have 70 over 126, and I need to simplify this by dividing the greatest common factor out of the numerator and denominator. Okay, so first thing we're going to do, okay, this is your first step, step one, find the prime factorization. So 70 is 7 times 10, 2 times 5. So I'm going to write this down, that 70 is 2 times 5 times 7. This is the prime factorization of 70. Let's go ahead and do 126. Ooh, that's kind of tough. Let's see, I'll divide by 2 first. And I'll get 63. Okay, I recognize 63. 63 is 7 times 9. And 9, of course, is 3 times 3. So 126 is equal to 2 times 3 times 3 times 7. Okay, let's go ahead and move this a little bit because this is what we're going to focus on now. Once you have your prime factorization of your two numbers just like this, and I do recommend that you stack them right on top of each other, we're going to look for the biggest number that I can divide out of both of them. Well, I can only divide numbers that I can make out of the prime factorization. So what I'm going to do is I'm going to look for the numbers, these prime factors, that 70 and 126 share. Okay, and that means that they both have. They both have a 2 to give. Anything else? This guy's got a 5, no 5's down here. This guy's got a 3, no 3's here. The only other thing they share is a 7. So what that means is that the greatest common factor is going to be this times this. The greatest common factor is 2 times 7, which is 14. Okay? And that's all there is to it. I mean, there's a lot of different ways to do this. This is by far the fastest way. Now, that was with only two numbers. Oh, so if I were simplifying this fraction up here, let's go ahead and drag this thing over. If I were simplifying this fraction, what I would want to do is divide the top by 14 and divide the bottom by 14. And you can see, well, let's see, 70 divided by 14 is 5. And what's left after I take 14 out of 126? That would be 9. And I'm done. There's nothing else that I can factor out of 5 and 9. Okay? So makes big numbers, especially numbers that you don't know off the top of your head. I don't know all the factors of 126, and I don't expect you to. But what this gives us is a way to solve the greatest common factor problem for any numbers. Okay, now let's say we have three numbers, 36, 90, and 144. And I want to know the greatest common factor of all three of these numbers. That means the biggest number that I can divide into all three of these numbers. Well, we're going to do the same exact thing. 36 is 6 times 6, 2 times 3, 2 times 3. So I'll go ahead and write that here. 36 equals 2 times 2 times 3 times 3. And notice I do put my prime factors from least to greatest. Okay, done with 36. 90 is 9 times 10, which is 3 times 3. and 2 times 5. So 90 is equal to 2 times 3 times 3 times 5. 144 is, let's go 2 times 72, and that's going to be 8 times 9. And I know the 8, oh, I'm not going to skip steps here yet. All right, I've got a bunch of prime factors here. Let's make sure that I circle them and add them correctly. So I've got 2, 1, 2, 3, 4 2's, 2 times 2 times 2 times 2. And I hope you know that that means 144 is divisible by 16. And then also I've got 1, 2, 3's. All right, we're all done with factoring. Now, if I want to find the greatest common factor of all three of these numbers, well, I have to find the prime factors that all three of these numbers share. And I can see right here that I've got a nice 2. What else? Can I get another 2? No, because 90 only has 1 2 to give. Let's see, do they all have a 3? There's 1 there, and 1, sure enough. Okay, so let's write it out here. My greatest common factor is going to be 2 times 3. Okay, those are done. What else? I've got another 3. 1. Yep. All three of these numbers have 1 more 3 to give. Anything else? 5? Nope. 36 and 144 aren't divisible by 5. That's it. I'm done. So my greatest common factor, this number right here, let's go ahead and move this. There we go. Okay, I just want you to be able to see this. My greatest common factor for these three numbers is going to be 2 times 3 times 3, which is equal to 2 times 9, or 18. All right, now that's a very difficult problem to try and do in your head or even to do on paper if you don't know this method here. All right, now how do we apply that to real life problems? Well, there's one in your book that's kind of tough. All right, I'm going to read it to you right now, and then I'll do a little demonstration. A rectangular piece of metal sheet that measures 360 centimeters by 280 centimeters is cut into identical small square pieces. Find the greatest possible length of a side of each square piece. Okay, I'm not going to do that problem. So what I'm going to do instead is, why can't I get my toolbar? There we go. Okay, let's do this problem. This is a better problem. Let's say that I have a 20 acre by 12 acre, no, that can't be right. 20 kilometer by 12 kilometer field. Okay, huge field, right? And we want to cut this up into square plots of land to sell. Okay, so this is 20 kilometers going this way. This is 12 kilometers going this way. And, whoops. What I want to do is I want to cut this up into square plots. Okay, so how are we going to do that? Now, this might not seem like it, but this is actually a greatest common factor problem. Let's do an example here. So, what I could do is I could cut I could cut this big field up vertically, right? Now, the number that I'm dividing here is 20. Here I've cut it into pieces that are 1 kilometer long, and just ignore this where it says centimeter. Now you can see that I can cut it into 2 kilometer long strips. But look what happens when I try and do 3, okay? When I cut this thing up, 3, 3, 3, 3, 3, 3. Oh wait, what happens? Well, you can see that I get a chunk missing, okay? And we don't want that because I want all of these square plots of land to be the same size. That's very important. We want these square plots to be the same exact size. So 3 doesn't work. What else doesn't work? 4 works. 5 works. 6 doesn't work. Okay, if I cut this, if I go cut by 6, and then 12, and then 18. Well, I need it to land on 20. So I hope that you can see that the numbers that I can cut this 20-kilometer strip okay, so the numbers that I can cut this 20-kilometer strip into evenly are going to be factors of 20. All right, we can do some more. So if I did 7, you can see 7 doesn't land on, 8 doesn't land on it, 9, oh, look at that. 10 cuts it nice and evenly. Okay, so these are the cuts that I make here, these vertical cuts, have to be factors of 20 if they're going to divide in evenly. Now, if I'm going to make a square, I have to make horizontal cuts as well. Okay, and let's see what numbers work here. Well, 1 works, that's even. 2 works, 3 works, 4 works, 5 does not work. Okay, if I cut 12 by 5 and 5, I've got a strip that's 2 kilometers left, and I can't make even pieces out of this. Can't do it. Let's see. 6 will work because I can divide 12 by 6. 7 doesn't work. 8 doesn't work. Okay, so really this is the greatest common factor problem. I have to cut this thing up into squares that have a side length that's divisible, that divides into 20 and 12. Okay, so I have to be able to get these cuts in, and you can see what I'm looking at here, like this. Okay, so you can see I've got this big square right here and this big square, but these aren't squares, so these don't work. They all need to be the same size. Now, the greatest common factor of 20 and 12, I'm not going to do it with the prime factorization. The greatest common factor is 4, and you can see that if I cut this down to 4, there we go. I've got squares that cover my entire field, and I don't have any leftover pieces. Okay, 3 doesn't work. 2 works, but I can get bigger squares. The question is, what are the biggest squares I can cut into this field? Okay, 5 doesn't work because it doesn't work for 12. 6 doesn't work for 20, and so on. 7 doesn't work for either. You can see I have pieces here that are sticking out and pieces here. So that's kind of the idea with that problem. It's a tough one. You have to do the same thing with bigger numbers on your homework. All right, I hope that helped. Maybe with this field problem, I confused you more than I helped, but we'll go ahead and go over this in class as well. All right, bring me your questions. Thanks.